Hey you guys, we are going to talk a little bit about variability in this video lecture. I want for you to pull up your central tendency and variability PowerPoint if you can. It'll be easier for you to watch this and look at the PowerPoints at the same time. If you don't have access to them right now, then they're on Blackboard. You can get them from there. Or if you really just want to watch the video, I guess that's fine. But it'll be better if you also have the PowerPoints. Okay, so I'm going to start sort of by talking about just general variability, sort of at slide 14. I pulled up mine, so I'll be following that as we go, and I'll try to keep you oriented as to where we are. So on slide 14, this is just saying, what is variability? What are the different types of variability? So variability is just the degree of spread in a set of scores, so how far apart things are. So it's probably easiest for us to think about maybe exam scores or quiz scores. Because I'm trying to make the math a little bit easier for myself, I'm probably going to do quiz scores from 0 to 10. Okay, so you take a quiz, it's worth 10 points, so you can get anything from 0 to 10. So I'll be using that as a reference. Okay, so measures of variability. It starts out by just discussing range a little bit. So I'm going to go ahead and just jump into slide 15, which it talks about range. Range is pretty simple. The only thing that you have to do is you have to know the highest score that someone received on the quiz and the lowest score that someone received on the quiz. And you can take the lowest score and subtract it from the highest score. So you see on slide 15, we have this sort of an example where we have 10 quiz scores that have been given, and we see that the highest score that someone received was a 9, and the lowest score that someone received was a 1. So 9 minus 1 is 8, and 8 is the range, okay? Now, we don't use range very frequently, mostly because it's based on these two extreme scores. So what if most people on the quiz got a 7? But one person got a 1 and one person got a 10. Well, the range would be a 9, but that really isn't telling me what I really want to know about the variability in the data, especially because most people got a 7, and that's completely lost in the account of the range. So it's not the best measure of variability. So for that reason, I don't spend that much time talking about it in the PowerPoints, and I kind of jump right into the type of variability that we use the most often, which is standard deviation. So I have here in slide 16, it's saying standard deviation is the most common and important measure of variability, which is very true. So if you look at any academic paper that is reporting statistics, they will usually report a mean. So they'll have M equals something, and then they'll also have SD equals something. So anytime they're reporting a mean, they report the standard deviation that goes with it. So if you're just looking at the participants who took a study, right? A lot of times we report age. So we would say, we might give the range. So we might talk about here's the lowest score, here's the highest score, the lowest age, the highest age. But we also usually give the mean. So on average, how old were the participants in your study, right? So in a college sample, that's usually like 19.5 because most of our students are pretty young. But it's also important that we know the standard deviation. So on average, how far away are people's ages from 19.5, okay? So if I have a standard deviation of, let's say, 10.2, that's huge. I mean, that's saying that there had a lot of people who were 9 or 29, right? So there's a large age range in there. But most of the time with college students, our standard deviation is something like 1.4. Okay, so we're seeing like a little bit of variability in age range, but not much, okay, because most people are in this 18 to 22 age range. Okay, so it is going to be reported a lot. You will see it all the time, and I need for you to know that it is also, it's an average. It's just an average of deviations, and we're going to use that term deviations to refer to how far away a score is from the mean. So if you are 21 years old, then and the average is 19.5, then you are 1.5 points away from the mean, right? So that's your deviation score is 1.5. All right, so deviation scores are going to be really important for us. The calculation of how to calculate a standard deviation changes depending on if you're talking about a population or you're talking about a sample. So we're going to start out talking about what it looks like for a population, and then we'll move into what it looks like for a sample. It's not very different. It's just like a really small adjustment that we have to make. I have here that variance is a necessary component of the standard deviation. So whenever you compute the standard deviation, you automatically compute the variance first. So you're going to have that all the time, which is fine. Okay, so let's go on to slide number 17. So here you see this deviation score. So remember, this is how far away a score is from the mean. So here it's represented as x minus the mu. Remember, mu is the mean for the population. So you could easily replace that mu with an m if you're talking about a sample. Okay, but remember, I told you that the formula for standard deviation is different depending on if you're talking about a population or if you are talking about a sample. So that's something we're going to kind of try to keep up with as we go. So step one is just sort of going through and finding the deviation score for every single person in the study. So if you were doing age, you're looking to see how far is everyone's age from the mean of 19.5. I told you we would be talking about quiz score, so how far away is each person's quiz score from the average? That would be a deviation. So after we do that, we go to step 2, which is finding the sum of the deviations. So you're basically interested, you want the average deviation. So you know, for calculating average, you add them together and you divide by however many scores there are. Well, here, I kind of go into the problems. We have 2 problems here. The first one is that if you do this, where you try to add together all the deviations, you actually get an like it adds to 0, okay? So if the sum always adds to 0, this would mean that the average deviation is always 0, and that's not true, okay? So we need a different strategy. Now, one thing I will say is that when we are doing the math, if you add these deviation scores together and they don't equal 0, then that is bad. That's a problem. You've done something wrong, and you need to go back and make sure that that column is adding to 0. Okay, so let's go to 18. If you remember in class, I showed you this graph when I was talking about the mean, okay? And I was telling you I was just trying to make it extra complicated to understand what the mean was. And I was doing it mostly just so it would make sense when we get over here and we're talking about standard deviation. So slide 18 is identical to what you saw when we were looking at the mean. Okay, so I'm not going to spend too much time here, but this is sort of, we're getting back into this. In slide number 19, this is where I'm explaining the fact that we're having to do something different besides just adding together the scores, because the deviations, because they're always going to equal 0, okay? So our problem is that we have these negative deviations. And I talked to you guys in a class about this and the fact that these negative deviations have to be dealt with in some way. And so the way that we do that is we just square them. Okay, so we square every single deviation score and then we add those together. Okay, so that's going to be the step 2. I put revised because we can't just add together the deviation scores. We have to square them first. So step 3 is averaging the squared deviations. So when we do this, a mean squared deviation is the variance. Okay. So we're going to get to the formula really, really soon, and you'll see that, and that'll make even more sense then. Okay, so go back, we'll go to slide 20, which is the picture again, and you see here how it looks different when you square each thing. Okay, so once you start squaring it, then we're actually going to get decent sized number when we add together all the squared deviations. So you might want to take a minute just to look over the slide and make sure you understand what's happening here. It's sort of trying to take the formula and break it down into something that's practical and makes sense. Because you can just memorize this formula and say, oh, okay, I need to find the standard deviation, so I'm just going to do the formula, right? Without ever understanding a single thing about what standard deviation is, okay? So standard deviation, the standard deviation, on average, how far does a score deviate from the mean? That is what it essentially is trying to do and trying to get at. And it'll make your life easier if you wrap your head around what exactly it is, as opposed to just trying to memorize the formulas and do the math without ever thinking about it. Okay, so let's go to slide 21. When we're doing this, like I told you before, we'll always get the variance first. So let's say you have your scores, you calculate all the deviation scores, so how far is each score from the mean. You square all of those, all right? You add those numbers together, and then you divide by however many scores there are. That answer is the variance, okay? And ultimately, we want the standard deviation. So all we have to do to get the standard deviation is take the square root of the variance. So when we take the square root of the variance, we will have our standard deviation, and we'll be answering the question of, on average, how far away are the scores from the mean. Okay, so slide 22 is finally showing you the formula, which is nice. So we see this formula here. It's putting it all in one, where you see the formula for standard deviation without seeing the formula for variance. So I think in both of the classes I showed you the formula for variance. It's the same thing, it's just the standard deviation has a big square root over the whole thing, okay? Remember that the sigma just means sum of, right? So you're adding together, all right? So that, don't forget what that means, because that's going to come up over and over again. So you see, you started out with a bunch of x's, okay? You had those. You calculate the mean. You can do that just with the x's, right? You add them together, divide by however many x's there are, voila, you have a mean, okay? Which here is represented as a mu. So now you have the x, you have the mu. You need a whole column of scores that represent the deviation, so the x minus the mu, okay? Remember I told you that when you add all those together, it'll be 0, and it should be 0. Okay, now the squared part, you have to take each deviation score, each x minus mu, and square it, okay? And then the last part of that numerator is the sum of, so then you're going to add them all together, all right? Divide by n, so divide by however many scores there are, and at that point, you have what's called the variance. But here, if we take a big square root over that number, you get the standard deviation. I wrote this out a different way here, where I've got the square root of SS over n. And that is just to show you that that numerator portion of the formula has a name, and it's called the sums of squares. Okay, so sometimes as we get further along, I'll talk about the sums of squares, or the sums of squares, and it's definitely in your chapter, in chapter 3. So sums of squares is the numerator portion of that particular problem. Okay, so let's see. 23, slide 23, sort of takes a little bit of a step back and shows you what just the formula for variance looks like. So it's the same thing you just saw for standard deviation, except it doesn't have the big square root over the whole thing. So take a minute just to kind of look at both of those formulas, see how they are the same, see how they are different. You'll really know if you understand this when we start doing a practice problem together, and then that'll tell you if you know what's going on. Okay, so I showed you on slide 24 just another way that this formula can be written, and again, I'm just making use of that SS term. So SS stands for sum of squared deviations, or sums of squares. It's what we frequently call it, okay? All right. All right, so On slide 26, we have the steps. So if you want like a step-by-step process on how to calculate a standard deviation, here it is, slide 26, 5 steps. First thing, oh, you know what? The first step kind of overlooks one of the initial steps. So it says, step 1, subtract the mean from each score. Well, you cannot do that unless you know what the mean is, so you clearly have to calculate the mean first, so don't forget about that. All right, so you subtract the mean from each score. You square each of the deviation scores, and this will give you what's called a square deviation score. You add all of those up. That's the sums of squares. And it's also the numerator in the variance equation. You divide the sums of squares by the number of scores, and then you take the square root to get the standard deviation. So I think we need to practice because sometimes it's hard to know if you really know what to do just by reading these instructions. So I have in slide 27 sort of like a recommended setup of what this would look like. So I have a bunch of scores here, some x's. In total, let's see how many x's there are. 1, 2, 3, 4, 5, 6. There's 6. Okay, so there's 6 x's. The mean for these x's is a 4. So you know that by just adding together the x's and dividing by 6, because there's 6 of them, right? So the second column is your x minus the mean column. So you should have, like, say for the first one, it would be 2 minus 4 will be negative 2. 4 minus 4 will be 0, 3 minus 4 will be negative 1, 5 minus 4 will be 1, 4 minus 4 is 0, 6 minus 4 is 2. Okay, so you see those. Remember, this column always adds to 0. If it does not add to 0, something's wrong. Okay, you've messed it up somewhere, so you need to go back and check it and fix it. Okay. Third column. This is where you're squaring every single deviation score, okay? So negative 2 squared is a 4. Remember, the negative signs were going to go away. So in that third column, you should only have positive numbers, okay? No negative numbers allowed over there. So then once you square all of the deviation scores, you add them together, and that's where you get your SS. That's sums of squares, the sum of the square deviations. It makes sense, I think, right? Adding together the square deviations, sum of square deviations. I think it makes sense. Okay, so I have the 10, and you might be looking at it and you're like, how did you get from the 10 to the variance of 1.67? Well, you take the 10 and you divide by n, and the n here, the number of scores is 6. Okay, so when you do that, you'll get a variance of 1.67. And if you want the standard deviation, which normally we do, you take the square root of that 1.67 and you get 1.29. Okay? All right, so I think we need to sort of do one together, little project here. I'm going to have to turn this a little bit so you can see it. Maybe this will work. All right. Let's see. What should we do? We're going to have some X's. Now, sometimes it'll be a little tricky because you're going to get used to seeing it's like, oh, here are the X's or whatnot. But most of the time, they're not presented that way, right? So they might be presented as just regular numbers. So if we did ages, I'm going to have to pull out my calculator. All right, hold on. So if we did ages, I'm pulling out my calculator so I can do something beyond 0 to 10 for you, because that might be better. Let's do ages, okay? So instead of having X column, essentially I have ages, but it represents X, okay? So don't get confused by that. It's not trying to confuse you. It's just saying that we're not calling them X's. We're calling them the ages of people. So we're going to do the ages of, I don't know, people. I don't know if I want to do in my class. I don't know, just maybe the ages of people that you run into on a daily basis. That'd be kind of easy. Okay, so for me, I run into tiny people very first thing. So we're going to have 3 and 7. definitely run into them first, okay? But let's just say you're going about your world and you run into someone who's 20 and someone who's 18 and someone who is 62 and 45. Maybe say you run into another little child here. So we're, I'm missing it. Okay, I'm going to stop because I'm getting too far on the board. Okay, so these are the people who are in this particular survey or study or whatnot. So I have a 3, a 7, a 20, an 18, a 62, a 45, and a 2. So I need, very first step in all of this is maybe just to identify the n, okay? So I usually write that out over here. The n, remember the n is the number of scores. So we've got 1, 2, 3, 4, 5, 6, 7. 7 scores, okay? But I need the mean because I really can't do anything until I get the mean. So that's why I'm busting out my calculator over here. So I'm going to have 3 plus 7 plus 20 plus 18 plus 62 plus 45 plus 2. Okay, and I got 157. Now, remember, is that the mean? No, it is not. It is just the sum. So, So in order to get the mean, I'm going to take that 157 and I'm going to divide by however many scores I have. So in this case, I have 7 scores. So it's going to be 157 divided by 7. And I get 22.43. This is going to be very fun. Okay, 22.43. You see that? All right. All right, so I'm moving on now to try to get towards my variance and my standard deviation. Very first thing I need to do is start working on these deviation scores. So I'm going to put x minus, I'm going to put mu just because it's going to make sense in terms of the formula that we're using, so I'm going to use that right now. Okay, so 3 minus, 3 minus 22.43 equals negative 19.43. Okay. 7 minus 22.43 equals negative 15.43. 20 minus 22.43 equals negative 2.43. 18 minus 22.43 equals negative 4.43. 62 minus 22.3, 62 minus 22.43 equals 39.57. 45 minus 22.43 equals 22.57. And 2 minus 22.43 equals negative 20.43. Wow, that was fun. Okay. So something that would be a really good thing for you to do here is to add these together and make sure that they come out to equal 0, okay? Because if they don't come out to equal 0, we've done something wrong. So we're going to add together the negatives, I think. It's usually easier for me to just add together the negatives and then balance them out with the positives and make sure it's 0. So we'll do the first one, 19.43 plus 15.43 plus 2.43 plus 4.43, and we'll go to the other negative, plus 20.43. So on the negative side, I have 62.15, so I just need to make sure on the positive side it's 62.15, okay? So 39.57 plus 22.57. Okay, so it's 62.14. So this is a great example of the issue of rounding. I think I mentioned this, at least in one of the classes I mentioned this. Because there's so much rounding going on here, and in the calculation of the mean itself, we might have a situation where it doesn't equal exactly 0. So in this case, it would equal negative 0.01, I think. And that's okay. It's just a rounding problem. Okay, so it just needs to be really, really close to 0, if not exactly 0. Okay, so this is even going to be even more fun on my calculator because my third column here, taking all these deviation scores and I'm squaring them. Okay, so we've got 19.43 squared equals 377.52. 77.52. Okay, 15.43 squared, 238.08. That's right, yep. 2.43 squared, 5.90. 4.43 squared, 19.62. Okay, 39.57 squared. Oh, good heavens. 1,565.78. Okay, 22.57 squared. 509.40. Last one. 20.43 squared equals 417.38. Okay. All right, that was fun. So I've got all of my squared deviations. Okay, so if you remember, I don't think I wrote the formula on here anyway, so let's see if I can prop this up and I'll at least do the variance one. Okay. So we've got variance equals the sum of x minus mu squared divided by n. Okay, so, So in this particular case, we have done the numerator, okay? Oh, actually, we haven't finished. So we did this part, we squared them, now we got to add them together. Once we add them together, this will be done, and that's called the sums of squares, okay? So we do need to add all these together. So fun. Okay, so I have 377.52 plus 238.08 plus 5.90 plus 19.62 plus 1,565.78 plus 509.4 plus 417.38. Okay, so it's a big one. So the sums of squares. So when we add it all together, chop this down a little bit. When we add it all together, we get 3,000. 133.68. Okay, so that gives us our beautiful sums of squares right here. But in order to get the variance, we need to divide that by n. Okay, so I'm dividing it by n, which is 7. Okay, so let's say divided by 7. All right. Ooh. So for the variance, I get 447.67. Now, if it comes out a little differently for you, what I did was I think I kept the full total here instead of rounding it to 0.68 and divided by 7. So if it's different, that's probably why. Okay, so variance, 447.67. Now, like I said before, we always want the standard deviation. So I'm going to take the square root of my 447.67. Okay, and I get 21.16, which is saying, on average, the extent to which scores are deviating from our mean Remember, our mean was 22.43. So the average deviation is 21.16. Okay? All right, so hopefully that made sense to you. You are definitely going to have to be doing some work with that for your homework. Okay, so it's going to be important that you understand variance and standard deviation and the things that we talked about in class when it comes to like the mean, the median, and the mode. If you have questions, of course, feel free to contact me, to email me, and I will get back to you as soon as I can. And I think that's it. I look forward to seeing you again. Make sure that you are going through these PowerPoints, that you're going through Chapter 3. You have this video you can access if you need it in the future. It's not a bad video to come back to when you're studying for Exam 1. So hopefully that'll be helpful to you. But anyway, okay. I hope you have a wonderful time studying and looking over your homework, and I will talk to you soon.